Okay. Last day I forgot to record. Did any one of you record last day's session? I'm asking because
Not
I'm
that.
doing it for you only. I just forgot. Okay. So from next day onward, any one of you should remind me whether I have started the recording. Okay. Let me present. Is the slide visible?
Yes, sir.
And am I audible enough? Loud enough?
Yes, sir, enough.
Yes, sir.
Okay.
Yes, sir.
So welcome to lecture 2 for the course Software Quality and Reliability. In lecture 1, we learned about software quality assurance, specifically the definition of software quality assurance and other related terms, and like software product, the principle of software quality assurance, software errors, faults, and failures, software quality assurance versus software quality control and the basic difference between them. And also we have learned the basic difference between software engineering and software quality engineering. So today we will learn software quality factors and components. So this is the outline of today's lecture. First we will know what the software quality factors are. Then we will learn a very basic but very important model for software quality factors that is proposed by McCalls, which is called the classic model for software quality factors. Then we'll learn a standard model for software quality factors, that is ISO and IEC 25010 model. Then we will also briefly know about the other alternative models except these two models and the associated quality factors. So let us go one by one. So to understand the software quality factors, let us read these customer complaints first. So assume this is a complaint raised by a customer to a software company. Like our sales information system generates invoices and inventory record appropriately with correct calculation of our complex discount policies. However, there is a serious issue with the system. It frequently fails at least thrice a day and each time at least for half an hour. Yesterday morning I did not work for approximately 2 hours. We need your maintenance team support, sir. So this is one complaint. Another complaint, like the XYZ country's police radar system has launched by ABC company, any company. It was very attractive and one of the most successful ones. Our company decided to make an Indian version of the same product or system. We therefore took over the ABC company. However, when we started working, we observed that the software has neither properly documented nor any standard methodology has been applied to build the same. As a result, we could not reuse anything. We had to build the entire system from the scratch. Then third complaint, since last year, the VCAT system of, I have just given means random name. VCAT system for our university was working absolutely fine. However, due to the COVID-19 lockdown, the maintenance team is not there in the office, and as a result, it has started malfunctioning. Whenever we are trying to contact the development team, they are claiming that they cannot do anything unless they are there in the campus, as the failure detection process of the system has not yet been developed properly. Then complaint 4, the PQR system, any random name, for employees of our company is very good. However, it takes at least 2 months to train a newly joined employee to make them acquainted with the software. So these are the 4 complaints. Now, in all the complaints, a common term was there, you have probably noticed, which was highlighted with bold font. However, so all these software systems satisfy almost all the basic correctness requirement. However, every software project suffered from at least one of the following, like software maintenance, software quality, software reuse, and user training related issues. In other words, the software packages fail to fulfill all the maintainability, training, usability, reliability, reusability issues. So this was because probably during the development process of the software, these aspects are not taken care of the development teams. So the common causes, reasons for these quality aspects are classified into content groups. So whatever the reasons are there, they are classified into some specific groups. These groups of reasons of software quality aspects are termed as quality factors or attributes. So let us now see one by one what are the different models exist for these quality factors. As I mentioned briefly earlier, that McCall's model, which was proposed by McCall et al. In 1977. So this is called the classic model of software quality factors. So they have classified all the factors into 11 software quantity group, quality group, factor groups like correctness, reliability, efficiency, integrity, usability, maintainability, flexibility, testability, portability, reusability, and interoperability. Therefore, these are now you can observe that some of these factors, say for example, the first five factors deal with the requirement that directly affect the daily operation of the software. Therefore, these are grouped into a particular class called product operation factors. Similarly, maintainability, flexibility, and testability falls into product revision. Therefore, these are called product revision factors, and portability, reusability, and interoperability factors come under the product transition factors. To remember, you can refer to this diagram that is designed by the McCall et al. Themselves, where product transition, product operation, and product revision are presented as the main three roots of the quality software tree. And each of these factors are then factors of these three categories are again presented as sub roots of this main tree roots. Now let us know each of these factors one by one. So what is correctness, what is reliability, what is efficiency, what is integrity, and so on. So correctness uh, is defined as correctness is all about the uh, accuracy, completeness, and this type of thing. So it is therefore called the multidimensional factor. That means one or more factors are there, or more sub-factors are there, in fact, for this correctness. Because correctness is itself a factor, so these are the sub-factor for this correctness factor. So that's why it is called multidimensional factors. So all these dimensions are related to output of the software system. Like accuracy it says that the output should be accurate at least for 99% cases. Suppose in a payment system, payment calculation should be 100% accurate at least for 99% cases. So payment should not be miscalculated. Then completeness, it says that the output should be complete at least for 99% cases. For example, if you print the address of the employees, so at least for in that case, at least for 99% cases, no information should be absent. Like phone number should not be missed, or address should not be, or PIN number should not be missed in the address. So the completeness of the information should be there. Then up to dateness, it says that the output should be updated with probability of 99.5% cases. For example, the salary data or payment date should be updated within 1 day or within 2 days with 99%, 9.9% probability. And finally, the response time, which says that the output should be appeared within very short time. For example, after clicking the find item button or find employee button, the item should be appeared within 2 seconds or within 1 second. So the response should be quick. So all these are related to this correctness. So correctness is therefore a multidimensional factor. The sub factors, so dimensions are accuracy, completeness, up to datedness, and response time. Then coming to the reliability. So reliability deals with failure to provide a service, maximum allowed software system failure rate, maximum allowed percentage of system downtime, and maximum allowed average recovery time. For example, the failure frequency of a heart monitoring unit or any medical computing system that are generally operated in hospital, so they should not be fail frequently. It required to be less than 1 in 20 times. And downtime should. Is there any issue? Okay, no problem. So in bank, another example, the banking system downtime should not occur frequently, and even if occurred, it should be recovered within 5 minutes, for example. So so many customers are maybe in the queue, so it should not be down for a long time. Then efficiency. So efficiency deals with the hardware resources, computer processing capability, which are generally measured in million instruction per second or million cycle per second, which is commonly known as megahertz, and data storage capability, which are generally measured in GB, TB, etc., and data communication capability, which are generally measured in Mbps, Gbps connection, etc. Now answer one question. Any one of you, for the time being, assume that all of us are running only Microsoft Teams application and PowerPoint application, and the bandwidth of our internet connection is also same. But your computer, which you are using, is of very high configuration, latest one, and mine is of low configuration. Now tell me, whose system or which system is more efficient, yours or mine? Any one of you? I'll give credit for this.
Sir, our sir.
Have you got the question? Should I tell it again?
Yes, sir. God question, sir.
No, here the case is, what is your name?
Karim.
Karim. Okay, good that you have attended. So here the answer is the opposite. Means mine is more efficient. Why? This is because we are performing the same task, same operations, same set of operations, but I am performing the same operation with lesser resources. Got it? Understood? I am
Sir.
performing the same set of operations which you are performing, but I am performing that with the minimal resources. So my system is efficient. So when say for example you want to store your name, so it may be maximum of 50 characters, right? So when you write a program or when you define a array of string like this to store your name, do you allocate 1 GB of memory for storing your name? No, right? Just few byte of array of size maximum of say for example 50 bits. So when you are performing the same operation but you are using less resources, then your system is more efficient. So efficiency is thought in that way. Now integrity. So integrity deals with the software system security. So requirements to prevent unauthorized access and also the access control, right? Who can read, who can write, who can download. So all these options are there when you access some contents. So integrity takes care of all these things, like who can view only, who can edit only. You can see in the Google Drive also, right? So and you whether you are at all allowed to access, allowed to read, allowed to write. So some login is required to do that. So all these are taken care of by this integrity. Then coming to the usability, so it relates to the operation and training. Productivity of the user is the average number of successful transaction per hour. Training time, average time spent for training a new employee. So in Mackel's model, the usability is defined in two directions. One is the productivity of user and another is training time. But nowadays the usability is defined and measured in an extensive way, which we will discuss those in some later session. So this is the usability definition as per Macall, but this is not the advanced definition. So we'll know the advanced definition of usability later, and this usability itself a broad research area now. Then maintainability. So it deals with the time and effort needed by the user and maintenance teams to identify errors, reasons for the software failures, correct those failures, and after correcting those failures, also to how to verify those whether the correction is made properly or not. So all these are comes under this. All these come under this maintainability factors. Then flexibility. So flexibility deals with the capabilities and effort required to support adaptive maintenance activities. The capabilities include the resources in man days required to adapt the software packages to a variety of customer with the variety context of activities and a different range of products but of the same trade. For example, to make it clear, for example, suppose your bit of software application deals with the documentation of student performance and achievements, calculation of final grade, and so on. So everything is does perfectly. The software specification included the flexibility requirements, like the software should be suitable for all teachers, subjects, and all level, starting from primary to secondary to tertiary. So when all these are also included in your bit of application, then we can say that the flexibility factors have been included. Flexibility factors are there in the bit of applications. Next is testability. So it deals with the testing process of the software system as well as with its operation. So standard test data set is required to test the functionality and automatic diagnostic checks to detect the regions of the failure if any. Is the recording going on or it has stopped?
It's going on, sir.
Can't see. Okay, thank you for this one. So standard test data set is very much important to test the functionality of each function, each module of your software, and some automatic diagnostic tools are sometimes used to check and detect the faults failure and to recover the same as well. Then portability. So portability relates to the application of the software system to other environment consisting of different hardware, different operating system, and so on. So suppose you have built a system for Windows, so the with some minor modification, you can you should produce another version of that product or software system which runs in the Linux system. So these things are also considered for a good quality of build a good quality of software, and that's why this is another factor, important factor, which is called portability. Then reusability. So reusability is again thought in two directional, two dimension. So it is called, that's why it is called two dimensional or two directional factor. So suppose when you are building a software, you are developing a software. So whether you can, in that case, whether you can reuse some component of an existing software or not. So that is one kind of reusability. So this is reusability definition in one direction. So you are developing your software. So in that case, you are searching for the modules or searching for the component or an entire software which can be reused. It can be copied and reused in your application or software. This is one direction. Another reusability can be thought in another direction, like when you are developing a software, so you are thinking for the future. So say for example, I'm using a particular software, so whether this module can be reused to another future application or not. So in past direction and future direction, in both direction, this reusability applies. Then interoperability. So this interoperability focuses on on certain on creation of interfaces for other software system or equipment firmware. Suppose you are building a software system for medical laboratory. Okay, and there are some other existing software for doctors and nurses, for example. Then you should think about the interfaces to link the laboratory system with the physician system or doctor system or nurses system. So this interoperability should be there to make a high quality of software. That's why the interoperability is also a factors for software quality. So these are all about the factors which are present in the Mac's classic model or basic model or software quality factors. Now we will learn the IEC stands for the International Electro Technical Commission. Is there anything wrong? Okay. So some sounds are coming. Anyway, so what is the full form of ISO? I have told just right now. And IEC? Anyone who can answer will get credit. So ISO stand for International Organization for Standardization, and IC stand for International Electrotechnical Commission. So these are the standard body, standard organization who take care of this standardization of the product. So in ISO IC model, we can find 8 factors, namely functional suitability, performance efficiency, compatibility, usability, reliability, security, maintainability, and portability. Now, among these, 4 are included in the McCall's model itself. Like we have already know what is usability, reliability, maintainability, and portability. Those are already defined in McCall's model, the classic model. So these were defined as it is. So we will not discuss those, but let us know the other 4 factors, how they are defined. So first is functional suitability. So the capabilities to fulfill the functions needed by the customers, either stated or implied. So it is not mandatory that always all the functions will be written in the specification document. So they may be written in that document or maybe implied. So suppose the customer is expecting this means they are expecting these also. So all these expectations should be fulfilled, and it covers wide variety of aspects of software use such as accuracy and completeness. Now my question is, which of these factors of Merkel's model is or are similar to this one? Can anyone answer? Hello, is there anyone? Can anyone like to answer? Which of the factors which we have learned in case of Merkel's model? So which of them is or them is or are similar to this particular factor called functional suitability? The answer is correctness, integrity, and interoperability, which we have already. So these are somehow mapped to those in classic model. Then another new factors defined in this ISO IC model called performance efficiency. So it relates to the amount of hardware resources required to fulfill the software system task. Now same question. Which of the factors of Merkel's models is or are similar or exactly the same to this one? Venkata, Karim, you'd like to answer? Okay. So the answer is efficiency. Efficiency is exactly defined in this way in case of Merkel's classic model. Then compatibility. So it refers to the capability of the software system or component to exchange information with other system or components and perform other system required functions, sharing its hardware system and software environment. Again, similar question. Which of the factors of this Merkel model is similar to this one? So it may not exactly, but somehow related to the interoperability factor of Merkel's model. The interoperability factor says the similar thing. Then security. So it relates to the capability of a system product to protect the software system, data stores, and information produced from the reading, modification, or destruction by unauthorized person of system. So which we have already discussed in Merkel's model with a different name. What is that?
Sir, integrity.
Exactly. Very good. Who answered this?
Sir, Karim, sir.
Karim. Very good, Karim. So, so if you relate in this way, it will be help to remind you all these things. Otherwise, it will seems like only some definition. You will not get any interest. So now, till now, we have some idea about this. What are the quality factors and what are the different models like Macal, classic models. Classical model is there. Then standard model is there. Now we will know briefly about the other alternative model and associated quality factors. What are the other model exist and what are the factor associated with those model. So there are a lot of models which are developed during this 1990s and 1980s. So in addition to this ISO IC model and classic model, so several models have been built as I have already told, like Boehm's model, then Farb's model, which I have enlisted here, Evans and Martin's model. So the list is actually endless. The list you can find a lot of model and they defined the quality factors in their own way. Like for example, to elaborate, we have uh, seen that the security is defined in a similar way, where the integrity is defined in case of I in case of classic model. So in all these model you will find many new names of the factors, but and they have defined in their own way. So we will not go into the details of each of these models because the list is endless, I already told. So it may not be possible to remember all the models and in which model what are the factors, just and there is no meaning just to remember these names. We actually have to understand what are those. So instead, we will know some of the important factors which are not included in the list of the factor of ISO-IC and McCall's model. So that will probably help you better. So one important factor which is not present in the neither in this McCall's model or nor in the ISO-IC models. So effectiveness is defined as or it relates to successful completion of task including schedule and error frequency consideration. So this is included in the state of the art usability matrix. So that's why I was just telling that sometimes the name is different but the things are same. So nowadays, in the state of the art usability definition, this is the effectiveness is used as the as one of the metrics. Then evolvability, so which refers to the effort required to fulfill future requirements for software system changes and to adapt the system to technological developments and changes in the operational environment. So it is very similar to this McCall's flexibility factor. Then human engineering, so which deals with the man-machine user interface with the application of software, the case, the ease to understand and work with the application, the ease to perform and communication involved with the working with the applications. So this man-machine interface is very much important. This man-machine interface or user interface is now termed as HCI, human-computer interaction. That is itself one of the hottest research and study area in present days. So this human engineering, they named it as human engineering. After that, some man-machine user interface, they were termed as man-machine user interfaces. Nowadays, it is termed as human-computer interaction. So in human-computer interaction, you will get all this state-of-the-art definition of usability, effectiveness, and the factors and their factors like effectiveness, efficiency, learnability, then memorability, then satisfaction. All these things are there in the usability, in the state of the definition of usability itself. Then modifiability. So it refers to the effort that will be needed to modify the software product according to specific requirements of customer. So it is again similar to the Maxwell flexibility factors. Then satisfaction, which is very important. So if your customer does not satisfy with your software product or application, they will very important. So what does it refer? It refers to the which other users are also there. So generally, end user are there who directly use your application. There are some intermediate users like vendors and all these things. Some maintenance teams are also there, so they are also the users. So users are a lot. So it refers to the user's perception of the extent the software product meets user expectation in relation to the requirements. The degree of complete provision of all specified requirement has substantial impact on the level of user satisfaction. So this is also included in the state of the art usability matrix, as I already mentioned. Now one assignment is there for you. So we have learned what is the basic model or classic model of this software quality factors. Then we have also learned a standard model, ISO IC standard model for software quality factors. Now your task is to prepare a list of 20 quality factors which are not present in the Maxwell's classical model and software quality factors of software qualifiers and complete the following table. Like in first row, so you have to make at least 20 rows in this table. And first row you have to name first column, second column. In fact, first column is for serial number. Then second column you have to write the name of this quality factor. Then how it is defined, what is the definition of this quality factor, and if there are sub factors or not. Like uh, some factors are multidimensional or two-dimensional or three-dimensional, we have discussed. So if there are any sub factors or not, you have to mention these sub factors, and which where you did find it means what is the associated model. So like for example, satisfaction can be found in ICEC model or the Maxwell's model or some other model. So you have to write the name of the model and from where did you get this. So you have to mention the book or material or in a standard document, anything. And you have to also identify whether this particular factor is similar to any of the factor of the basic or classic Maxwell's model. Understood? Karim?
Yes, sir.
So what you have to do, it is clear, right? So you have to
Yes, sir.
name 20.
Sir,
Yeah,
in Mac calls model, there are 11, no, sir.
yeah. So
Not that
other than, yeah, other than this 11 model, you have to find
another one,
some,
sir.
yeah. Like
Okay, sir.
like in ICEC model, 8 were defined, but
Yes, sir.
4 of them were common to this Maxwell's model. So you can list 4 from there itself, right? So 4
Yes,
models
sir.
are not, 4 factors are not present in this Maxwell's model. So in this way, I have given you the list. I have also given you the book reference. If required, ask me. I'll send it in the PDF version of the book also. But you have to read all this model and you have to list the at least 20. If you can do more than 20, then it is better. But you have to do a list of at least 20 factors.
Okay, sir.
Okay. So to summarize, we have learned what is software quality factors. We have a brief idea. When we'll go through and you will go, I always suggest you to read some books, textbook or any reference material. Then it will also clarify the things. And even after that, if you don't understand or if you face any difficulty, you can talk to me. I'll clarify those. Okay. Then McCall's classical model, specifically the very basic model or classic model, which was developed by McCall's. And then we have also learned a standard model for software quality factors, which is called the ISO IEC 25010 model. And we have also a brief idea about the other alternative models and the associate factors with those models. So whatever I have covered in today's lecture was taken from this book, particular book, Software Quality Concept and Practice, published by IEEE Computer Society and IEEE Press, and which was written by Daniel Glein. So the topics I have covered you can find in chapter 2, section 2.1 to 2.5, and those who are interested can read the whole chapter. It will make you clear, means you will have a more clear picture of this. So in next class we will learn about the development and quality plans. Till then, thank you. If you have any specific query, you can ask. Any query?
No, sir. Thank you, sir.
Okay, so I also want your continuous feedback. Suppose you are if you are not getting the things, or I am going too fast, or I am going too slow, so you can tell them without, tell those things without any hesitation. Okay, so that
Okay,
we
sir.
can learn in a better way. So if the lecture is boring, neither you will be interested nor I'll be interested. I'll find that no one is responding, no one is there to learn my words or hear my words, and you will also get bored and you will not understand the subject. So if you face any difficulty, you can say without hesitation, I'll not mind, I never mind. Okay, so assuming that today there is no question, and let me end the presentation and stop the recording. You can ask the question offline also. After reading some materials, if you are not getting that, you can mail me or you can call me anytime, no problem. Okay, so let
Okay, sir.
me first download your attendance. Okay, and then I should stop the recording also. Okay, thank you.